Hey, my friends. Mr. Casey here again. I'm going to take you through a quick run through of the muscular and skeletal system today. I'm going to put this on Edpuzzle and then ask you a few questions. When those questions come up, take notes. So, hey, a muscular system, muscles are organs that move our body. Our skeleton holds us together. They cannot move without our muscles. We have more than 600, closer to 650 muscles in our body. They're approximately 40% of our body mass, almost closer to 50%, I think. But I'll go with 40% here. So much of our mass in our body is made up of muscle. Here's an image of just some of the muscles. One of the posters hanging on my classroom door. If you want a closer look, I will click on this here. The human body exhibit muscles. You can see it pull up. You can see that I searched human body exhibit muscles and went to images, and there are the images of the muscles. So if you want a closer look at those, go for that. Gonna get us back on. Here we go. So muscles, they contract, the muscles become shorter. Here you can see the bicep muscle is contracting. It's going to get shorter and pull up the arm this way. The tricep muscle on the backside will extend if you want to flatten your arm out. Okay, the messages, the signals that come to do this come from our cerebral cortex, come from our brain. Different regions of our brain are going to control different things. They're sent down our nerves, typically through our spinal column here, and into the muscles that send contract. Okay, we've got muscles, we've got our radius and our ulna and our bones here that we're going to see our skeletal system today. They're attached to our bones to make them move. Voluntary muscles are ones that you can control with your brain. Involuntary muscles are the ones that we do not control. We've already talked about some of those and some of the systems we've covered. Our heart is involuntary. We don't have to think to make it beat. When we eat food, that's involuntary. Okay, many or most of our organs, especially that are open, have involuntary muscles that allow like food to travel through it, air to travel, that kind of thing. So they were not ones we think of. Our voluntary muscles are the typical ones that can tell to our skeletal system that we have to think of to use. Okay, so just slightly different here. Again, looking at the three main types now. We've got the heart muscle, cardiac muscle, the skeletal muscle connected to the bones, and the smooth muscle are the muscles in your organs that we don't control, that we don't think of. The one difference there is that cardiac muscle does have stripes on it, is striated, but is not one we can control. Skeletal muscle, most numerous, they're striated, they're attached to bones with tendons. So if we were in class, we would dissect a chicken wing and we would look for these tendons right here that hold muscle to the bone. This could be a muscle coming off here. It's attached with this string, or that could just be a pry. It does actually look like a muscle, but it's not. This is just showing us just the tendons connected to the bone. When we flex the muscle, it pulls on the tendons, which pulls on the bones. Smooth muscles, not ones we think of. Stomach, intestine, uterus, contracts and relax slowly, no striations. Cardiac muscle in the heart, it is striated. It contracts 70 times a minute on average. All right, so it's just movements, result of pairs working together, a push and a pull, and we'll talk about that. Okay, one is pulling, one is pushing, opposite attraction, opposite muscles here. They're called flexors and extensors. One flexes, one extends, flexors and extensors. And when we use it, we use glucose, we use energy to make our muscles work. That energy turns into heat, which we sweat off if we get too much going, if we work out too hard. But that heat also helps keep our body temperatures constant. And over time, they become larger. Basically, what you're doing is you're breaking down the muscles when you use them. And then when they build them back up, they build up more muscles. They get bigger. So there are cells in there. They're kind of like stem cells, but it's a little bit more complicated. But for right now and for this week, we're just going to say, hey, you know what? You break them down and then you use protein to build them back up after they're broken down. That's why you need a recovery period after you work out. It's really when your muscles are recovering is when they're getting bigger. So you're using them and breaking them down, and then your body tries to repair them. And when it repairs them, they get actually stronger and bigger. So that's what's happening when we're working out. If your muscles are like bulging when you're working out, if you know you're doing push-ups or curls or whatever, that's simply because of an increased level of blood flow to that area so that you can use that muscle. But then it's the process after that that allows your muscles to get bigger. And there's a chemical that's produced. This is an interesting piece. Sorry to get sidetracked, but there's a chemical your body uses to help repair those muscles. And some people respond better than other people. And they've done tests and studies. And it's really cool because some people can build up muscle size really easily. And some people could do the exact same workout and build up no muscle size because they're not producing this chemical that is needed to repair the muscles that way and make them larger. So some people who get really big and buff, they actually have a biological advantage to look that way. The other people may be equally as strong and lifting as much muscle, but not get as big. And now the other piece of this image here, which is really interesting, is that guy is super strong, but is not like sort of gigantic, right? His arms aren't. They're big, but they're not incredibly big. And that's because he's using quick muscle work there, like fast acting muscles. And what he's done is he's trained his body to stimulate those muscles quicker. So just really interesting pieces about the way the muscle system works and how biology is connected to it. And it's also coming straight from your brain, right? So it's the signals from your brain that are getting those muscles to work fast if you practice and work at it. So interesting points there. Skeletal system is made up of all the bones in your body. Each bone in your body is a living organ made of different tissues. So if you hurt a bone, there's blood vessels in it. There's it's doing work. It's a live living thing. It's not just this hollow. A lot of times students in 8th grade will think like, they're just solid masses or they're hollow. Either one really isn't right. So let's take a look at our skeletal system. The 5 functions. It gives your body shape and support. It protects the internal organs. Okay, so you see that big sternum in the middle here, protecting your heart right under here, and your ribs, protecting your lungs. All your muscles are attached to the bones, right? Your major muscles, your skeletal muscles are attached. Sorry, not all your muscles, but your skeletal muscles are attached to your bones through tendons. There are the tendons, the white cords running down the back of your hand here, attached to these muscles in your forearm. You've also got some muscles in your hand here, but they're attached to the bones so that your bones can do what needs to be done. In a lot of your, especially your larger bones, you are making red blood cells inside the center in your bone marrow. It makes red marrow. We also have yellow marrow. And then the skeletal system is where major quantities of calcium and phosphorus are stored. So we say calcium is good for your bones. We store calcium and phosphorus in our bones, and it does make them stronger when we're storing it there. The average adult has 206, but when you are born, you have 270. Those bones get fused together after you're born, and they become one bone. It's part of the process, right? So really, when we start growing, when the egg is fertilized and we're zygote, a lot of that is cartilage to start, and then that cartilage turns to bone. A joint is any place where 2 bones meet. So here's a joint here. So the thing that people often confuse is we know tendons hold muscles to bone. Ligaments are bands of tissues, this yellow here, that connects one bone to another bone. All right. So bone to bone. This is a knee joint here, and we're looking at this tendon right here. I don't know why this is in French. Sorry about that. So these are your ligaments that hold it. Your ACL is the one that runs through the center of your knee, holding your femur and your tibia together. It's the one that I tore. So there's if we were in class, I'd show you this really cool video of the actual surgery. This is the cartilage here. The white is the cartilage here. That's what prevents friction and rubbing from harming the bones when they're coming together. So if you tear your cartilage, that's what's happening there. You have three major ligaments. Why am I spacing on this? ACL, MCL, medial collateral ligament, anterior cruciate, and posterior PCL, ACL, MCL. I think there's a fourth, but I can't think. Maybe there isn't. Maybe there's just three ligaments holding your knee together. But those are what you tear, and you have to get repaired. Our ligaments do not grow back. Okay, so if this tears and is gone, which when I looked at my knee image under the with my doctor, he pointed to the image and said, "You see right here, this is where your ligament should be. You don't have one anymore." So mine was shredded and gone. So what they do is they took a tendon. It's really cool. Took a tendon from my hamstring, the thing that connects my muscle to my bone. And my hamstring's pretty strong. And so they just take a piece of your tendon and they screw it into here, and then they run it through where the ligament belongs, and they screw it into this bone, and it holds it in place. So it's a really cool surgery. I'll post that for a fun thing to watch if you want to, for those of you that like that kind of thing. So here we've got the yellow bone marrow that I mentioned. We've got the red bone marrow. Yellow, these are where blood vessels are feeding the bone itself, and the bone is producing basically red blood cells that are very, very important for our body, and white blood cells that are also helpful, and obviously in fighting infections. The periosteum here is the outer covering around the outside of the bone. We've got the white cartilage cap, which is preventing friction and pain. But that's, basic structure of a bone there. Compact bone is the really strong. It forms at the outer shell of the bones. That's where the calcium is stored. It's got the blood vessel passages. And then the spongy bone is sort of the shock absorber, right? It allows the bones not to break and be brittle every time we use that. It's like this honeycomb kind of structure at the end of the bones. And it's, it says porous here. So like there are openings or holes in it. We got the blood vessels all filling in there. So we got bones, joints, cartilage, and ligaments. Those are the key words there. And then just something to think of, we got the axial skeleton and the appendicular skeleton. Like you think of your appendages. So that's your limbs and your arms and legs. And then this is your axial is they're the functions again of the bone. This is kind of a quick little bit review. Spongy bone right here, compact bone on the outside, periosteum on the outside of that. There are different types of bones. That's okay. We can skip that. Got the long, short, flat, and irregular. I'm not going to make you guys know this. Normally, we would study a lot more than this. We would memorize parts, bones, memorize muscles, but osteocytes are bone cells that exist. Osteoblasts are bone-forming cells, and osteoclasts break down. We get a new skeleton like every 7 years. We're constantly taking down old skeletal cells and building new skeletal cells. And the more you use it, the stronger your skeleton gets. That's one of the issues with elderly people breaking bones, is that they're not out running and exercising, doing things they may have done when they were younger. And their bones get weaker and more brittle that way. There's also something called osteoporosis that we'll talk about later, maybe. As I was saying earlier, the human skeletal is primarily cartilage when you're developing. If you break a bone, there are different fracture types. There's a simple, which means your bone breaks under your skin. A compound fracture is when the bone breaks and sticks out of your skin. And a green stick is when it basically just splinters. That's not really good. You don't want that. This is where we were, axial skeleton. I'm going to jump through just because it's easier to see here. Here's the axial skeleton is the orange, and then the appendicular skeleton would be the yellow bones here. Now, typically, I would make you memorize most of, if not all, pretty much all of these bones on this image. You would have to memorize them. You're not going to have to do that this week, but just go through those, take a look at that. I'm going to post one of those purpose games on the classroom, and you can mess around with that if you want to. Again, here's axial versus perpendicular. Appendicular, axial, appendicular, appendages, the axis, your body's axis, your core, basically. If you think about it with your PE activity you're doing. Skull, vertebral column, and rib cage, protecting all the primary organs. These are essential for us to survive, is all what's in here. The axial skeleton, the skull. Here are all the skull bones that it's broken up into. How many bones are there in the skull? 13 suture bones in the mandible, 8 suture bones in the cranium. Suture means they're sort of stuck together. So we got all of these bones in here. Super cool. Again, I would make you memorize these typically, but that's okay. And this is sort of the regions of our brain that are not fused together when we're born. You have your soft spot in the back of your head that hardens as you grow, and this allows for growth so that your heads can actually get bigger. All right. I'm just going to skip a lot of this. Here's our vertebral column. You'll often hear of like, hey, I fractured my C6 vertebrae or whatever way, or I have a crack in my L5. L means lumbar support. This is the region of your backbone right here. This is your tailbone, your coccyx, and your sacrum. The L5 is the one that attaches. It is superior to your sacrum, but posterior to your, or inferior to your L4. It's above your sacrum, but below your L4. So you got the lumbar, the thoracic, and the cervical. So those are the vertebrae in your back. These are your backbones, and your nerves, your primary nerves running from your brain out to your body are running down through this. This is why breaking your back cannot be a great thing. And sort of the lower you break your back, the damage will be to the lower half of your body. But the higher you break your back, break your spinal cord, you're going to have less and less function. If these are nerves going out to your arms versus nerves going out to your legs. And nerve cells in your back and nerve cells in our body do not regenerate. So if we break them, they will not grow back and fix themselves. Super cool. Rib cage. So we've got 7 pairs of ribs that are actually attached to our sternum. Then we've got 3 pairs, 8, 9, and 10 that come in. Those are called our false ribs that come in and are attached there. They're not attached on their own. And then we've got floating ribs down the bottom here, okay, that 11 and 12 that aren't attached. They're just attached around the back here. They're not attached to anything in the sternum. So that's our rib cage. Super cool. Joints are where bones come together. I'm going to skip over most of this part here. So just looking at shapes of joints, we could look at our plane joint here, our hinge joint, kind of like a door opening, a pivot joint, your radius and your ulnar rotating over each other. That's in your forearm. Condyloid joint, it's in between. It's kind of hard to explain, sort of like this elliptical piece coming in. It's in your fingers here. A saddle joint. It's hard to explain. Sorry, I should explain better, but we can look these up if you wanted to, but I'm not going to quiz you on that or test you on that, but just know, this looks like a saddle coming in here, a ball and socket joint. Just know that we have different types of joints and that those different types of joints allow for different types of movement. Okay, we wouldn't want every joint to be acting the same way. So a hinge joint allows us this flexion and extension. Ball and socket allows our hips and our shoulders to move the way that they do. A gliding joint is more like in our wrists and our hands and our feet sliding. And then saddle joints allow our fingers. So it's just on our fingers there and our hands, and allows that kind of movement that we're doing there, which is just, you can move all of these parts of your body and think about how they move differently. All right, and I'm going to let you guys, if you want to, you can scroll through this, but different diseases and conditions of the skeletal system, between arthritis, that's rheumatoid arthritis, what it looks like inside the joints, bursitis, Burser-Sachs, tendonitis, which some of you may have had. And so that's, tendonitis in here, inflammation of your Achilles tendon. That's the tendon that's taking your calf muscle down to your heel bone here. And so that's what you've strained when you've injured that, right? So, that's what you picture right there. That's a strain. That's not supposed to be read there. Carpal tunnel syndrome, if you've ever heard of that, when you're typing on the computer, we're looking at these tendons right here in your fist and your fingers, okay? Osteoporosis affecting the elderly. Okay. This is the spongy bone. This is spongy bone in elderly, not nearly as strong. All right. Um, Again, same image there. Scoliosis, curvature of your spine. Kyphosis, different kind of curvature with your spine. Lordosis, different kind of curvature with your spine. Rickets um, result in softening of the bones. Gout, scurvy, all of these. Leukemia, blood cells in your body. So that's it for the bones and skeletal system. I will post this on Ed Puzzle and throw some questions in there. All right. Hope you guys are good. Sorry to talk so much.